Hello, statistics students. Here's a video on associations in categorical variables. We're going to be looking at conditional probabilities. The following table displays the frequencies of two attributes for the people in a random sample of a recent US Census. The two attributes are highest education level, less than high school education, college or higher, and current marital status, single, married, divorced, widow, judging on the basis of our sample in table 5.3, is there an association between marital status and having a college education? If there is, we would expect the proportion of married people to be different for those who had a college education and those who did not have a college education. So we would look at the married column and we would split these up with those who have a college education and those who do not. Perhaps we could find different proportions of marital status for each category of education. So then we could look at each level of education and to see if the proportions are different for each marriage status. In other words, if there is an association, we would expect the probability that a randomly selected college-educated person is married to be different from the probability the person with less than a college education is married. So we're getting into what are called conditional probabilities. And the language is important here. The probability that a college education person is married is different from the probability that a person is college educated and is married. So let's break down each of these separately. The first one is a person is college educated and is married. Let's look at this one, that a person is college educated and is married. In the and case, we're looking at everyone in the collection from this census and wondering how many both have a college degree and are married. So we're saying if we pick a random person from this collection out of the 665 people, we're looking for the people who are college educated and married, college educated and married. There's 98 out of the 665 people from the collection. But then if we want the probability that a college educated person is married, the difference here is we're asking for the probability that a college education person is married. We're taking it as a given that the person is already educated. So we're not saying choose someone from the whole collection as before. We're saying just focus on the people with college degrees. And of those who have a college degree, there's 143 of them. And of those people that are college educated, what proportion are married? Well, there's 98 of those college educated people who are married. So the probability is 98 out of 143. Probabilities such as these, where we focus on just one group of objects and imagine taking a random sample from that group alone, like in the second case, is called a conditional probability. The probability of a college educated person being married, we look in the row college or higher, and see there's 143 people who have a college education. Since there are 98 people in this row who are married, like we said already, the probability of a college educated person being married is 98 out of 143, or about 68.5% of them. We call this a conditional probability because we're finding the probability of being married conditioned on the fact that there's a college education. They have a college education. That is, we're assuming we're only selected from the college educated people. So it's under the condition that they're college educated. So let's look at that word given that versus and. Often conditional probabilities are worded with the phrase given that, as in find the probability that a randomly selected person is married given that the person has a college degree. So we're saying we can only stay in the college degree row and then look at the married entry. But you might also see it phrased as in the last paragraph, find the probability that a randomly selected person with a college degree is married. This phrasing is more subtle. It implies that we're supposed to assume that the selected person has a college degree. We must assume we're given that the person has a college degree. And the mathematical notation for conditional probability, it's a little unusual at first, hard to get used to, but after you see it a couple times, you'll start to get used to it. So we write P for probability such with the probability of the probability that a person is married such that given that the person has a college degree. So this is where the conditional statement, what comes after that is the condition. So we're finding the probability that the person's married, given that the person has a college degree. So we're stuck in the college degree row, and we have to find the column where they're married. The vertical bar inside the probability notation is not a division sign. You should think of pronouncing it as given that. The sentence reads, the probability that the person is married, given that we know this person has a college degree. And we know that's 98 out of 143, as we have seen. Some statisticians like to think of the vertical bar as meaning within that row or column, because we can do column conditions as well. The probability that we randomly select a married person from within those that have a college degree. So we're looking at the column within that column. Either way, you think about it as it's fine. Use whatever makes the most sense to you. So summarize, key point, it's the probability that A happens given that B is true. Means to find the probability the event A occurs, but to restrict your consideration to those outcomes of A that occur within event B. It means the probability event A will occur given that event B has occurred. As another example, let's look at that same table and find the probability that somebody is divorced. Sorry, let's find the probability that someone has less high school given that they're divorced. So we're going to find the probability that someone has less than a high school degree given that they're divorced or within the divorced column. So the less high school comes first, the divorced comes second, but that's the given that. So it's good to look at that one first. So it says, let's be within the divorced column. Given that they're divorced, we want the probability that they have less than a high school education. Less than a high school education, there's 10 out of 84 of those. So the probability that someone has less than a high school education, given that they're divorced, is 10 out of 84. And we typically like to turn those into decimals, 0.119, or about 11.9% of those in the divorced column have less than a high school degree. And so in subsequent videos, I'm going to show you, if we're not given a table like this, I'm going to show you there's other formulas for finding conditional probabilities, and we can use this to actually solve this probability. And this will be in a subsequent video. But for now, this concludes this video on associations and categorical variables, introducing you to conditional probabilities.